Yeah, just I would like to take you through how to calculate, how to estimate lower calorific value of syngas that is produced from gasification of wood. Just this is this particular calculation is important from SMN2 point of view. Of course, you also do similar kind of like LCV estimation of syngas produced from wood in your tutorials. But in SMN2 it is slightly different, and it's very important for you to understand the calculation part of the determination of LCV of syngas. Yeah. So yeah, first let us first let us start with uh, chemical formula of wood. As we all know, approximated chemical formula of wood is CH1.40.6. That means it has one element of carbon and 1.4 elements of hydrogen and zero point 0.6 of oxygen. So, stoichiometric combustion of wood in air gives stoichiometric means here in general in combustion it is complete combustion of any fuel. So, for the complete combustion of wood in air gives a CO2, H2O, and unreacted inert nitrogen. So the reaction here I am showing as an equation 1. So when wood this is reacts with air it is taken as 1 mole of oxygen and 3.76 moles of nitrogen. uh, we get carbon dioxide, water, and nitrogen. After balancing, after doing elemental balance, this we know, you know, and you do a lot of chemical equations balances in your tutorials. This you know how to balance. So after balancing, we get 1.05 moles of air is required for complete burning of wood, 1 mole of wood, which produces 1 mole of carbon dioxide, zero point 0.7 moles of water. So what does it mean actually? So yeah, and if you we can also calculate air fuel ratio of this stoichiometric combustion of wood. So by mass means mass of air that is participated here upon mass of wood that is participated here. We can always calculate mass of air when you know the number of moles that is participating in this. We know molar mass of oxygen is 32, molar mass of nitrogen is 28, and you know the number of moles of air that is participating. So we can get total mass of air that is participating, and also we know one molar mass of wood is 23, either in grams or kilograms. So by calculating air fuel ratio, we get it the value as 6.27. So what does it mean? It means 6.27 units, either in grams or kilograms, of air, a mass of air is required for complete combustion of 1 unit mass of wood. So uh, so for this complete combustion, the products that we get are, as I told in the earlier step, CO2 and H2O. If you want other products which has some heat value, which can be used for further applications, for the burning purpose. So what we need to do is, if air that participates in the combustion is less than 6.27 units, that results in incomplete combustion, and products will be like other than like intermediate products like COH2, CO2, H2O. Sometimes some fractions of methane, CH4 also uh, comes out. So this mixture is called as syngas. So this has some heat value. Heat volume means this if it is burnt in the presence of air, further it generates some heat which can be used for further other applications. So this is entire process is gasification of wood, solid fuel, converting solid fuel into gas, syngas fuel. So in this case, then how to estimate LCV, lower calorific value of syngas? So it's a straightforward. When you have wood, and so it's straightforward to estimate LCV of wood. LCV by taking stoichiometric combustion of wood. So, but when we actually burn that wood in the presence of less air, we get syngas. Then how to estimate LCV of that syngas? So, yeah, that's. Let me take into next portion of the calculation of LCV of syngas. Yeah, let us assume some air fuel ratio which is less than 6.27. Let us assume it as 2. Yeah, 2. Definitely, and also for simplicity, assume the products that will form as CO, carbon monoxide, hydrogen, and water. And water sometimes solid carbon, that is a char, also forms, uh, that which actually doesn't include as syngas. This is that goes as waste. So in this case, let us assume that the char doesn't form, and assume that only three products form by taking air fuel ratio of 2. Those are carbon monoxide, hydrogen, and water. So from that, yeah, we don't know from air fuel ratio. We need to estimate how many number of moles of air is required for stoichiometric combustion. Obviously, we know CO2 and H2O form. From that, we can easily calculate a number of moles of air required for that. Whereas in this case, this is not stoichiometric combustion. So in this case, yeah, here we know the molar masses of oxygen, nitrogen, and also this 23 is molar mass of wood. And from air fuel ratio, as I said earlier, air fuel ratio is mass of air divided by mass of fuel. So by using that formula, we can get the number of moles of air for air fuel ratio of 2 is 0.335. So we know now, we know the number of moles of air that participate in the reaction, and we don't know how many number of moles of CO, H2, and H2O form, and those are unknowns. But of course, by elemental balance, as there are three unknowns, and by elemental balance with respect to C, carbon, hydrogen, and oxygen, we'll get three equations, and we can find out three unknowns. So by doing that, we get 1 mole of carbon dioxide, 0.43 moles of hydrogen, and of course 0.27 moles of water, H2O, and this is inert nitrogen also forms. This entire gas composition, gas mixture is called as syngas. Now our task is estimating, calculating lower calorific value of this particular gas, which has some heat value. Okay. Again, the LCV means LCV of any fuel means that involves stoichiometric combustion of that particular fuel. Here now we are going to find out LCV of syngas. So we need to consider stoichiometric combustion of syngas. The LCV is defined as the heat energy release per 1 mole of syngas in general per 1 mole of any fuel. So this is the syngas that we got from the earlier reaction by taking air fuel ratio of 2. So when we actually burn that one in the presence of air, that so we get, obviously by stoichiometric combustion, we need to get CO2 and H2O, CO2 and H2O. So here one important observation is that, so the number of moles of CO2 and H2O that we are, and also nitrogen that we are getting from stoichiometric combustion of syngas are same as the number of moles that we got in stoichiometric combustion of wood. So this in the stoichiometric combustion of wood also we got 1 mole of carbon dioxide, zero point 0.7 moles of water, and this 1.05 times 3.76 moles of nitrogen. So according to the definition of LCV, we need heat of formations of all participating species in this. The heat of formation of CO2 is minus 394 megajoules per kilomole, and the carbon monoxide is minus 111 megajoules per kilomoles. Water is minus 242 megajoules per kilomoles, and for hydrogen, nitrogen, or oxygen, which are naturally existing molecules. So for that, at 298 Kelvin, heat of formation is taken as 0. So this is the important step, and you need to remember, even uh, in any tutorials or in even in the exam, if heat of formations of oxygen, nitrogen, and hydrogen are not given, you can take them as zeros. So yeah, as I told, this is important observation. So the step is, okay, how do you calculate LCV? So we need to determine uh, total enthalpy of the products that we get. These are the products: CO2, H2O, of course N2, and total enthalpy of the reactants. These are the reactants: the syngas and air. So we know all heat of formations. Heat of formations multiplied by a number of moles. For example, for CO2, the number of moles on product side is 1. For H2O, it is 0.7. So in the same way, in that way, we can get that. So the main important thing is, so it's a per mole of syngas we need to calculate. So how many moles of syngas is there here? So 1 mole of CO, 0.43 moles of H2, 0.27 moles of yeah, again I think this part again I will repeat. So we have so according to the definition as LCV, we need enthalpy of products, enthalpy of reactants, and the total number of moles of syngas. So in that, the enthalpy of products are CO2, water, and nitrogen. So to calculate the enthalpy of products, this is heat of formation is there per mole. So heat of formation times the number of moles that we get in the products. So for example, for CO2, we get 1 mole of CO2. So heat of formation times 1 mole of CO2. So it gives the enthalpy of total enthalpy of CO2 in megajoules. In the same way, for water, zero point 0.7 times heat of formation of water, that is minus 111 megajoules per kilomole. So in the same way, we need to get enthalpy of reactants. Here, as enthalpy of formations of hydrogen, nitrogen, and oxygen are zeros, I have not included those terms calculation in the calculations. So this enthalpy of products, enthalpy of reactants, upon this is the number of moles of syngas. So we have how many number of moles here? Syngas, we have 1 mole of CO. If you see the reaction, 0.43 moles of hydrogen, 0.27 moles of the water, and 0.335 times 3.76 moles of nitrogen, which we got from the earlier reaction of wood, incomplete combustion of wood. So after doing all those things, approximately the total number of moles of syngas is 2.959, around 3 moles. So we get minus 130.67 megajoules per mole of syngas. So this is, so overall it's a very simple. If you want to calculate LCV of any given fuel, for example syngas, instead of asking you to estimate how much amount of syngas what comes out when air fuel ratio is particular so and so, instead of that, if you are given with directly the composition of syngas, and if you are asked to find out LCV of syngas, it's a simple step. Directly you can write this stoichiometric equation. From that you can do. So so yeah, coming to the point, so yeah, as I told, in assignment 2, you do in 2 or 3 different questions, you're asked to estimate LCV of syngas. The assignment 2 is about gasification of food. So you get different composition of syngas with a different moisture content in wood, and different air fuel ratios. So for all those different compositions, you're asked to find out LCV of syngas. In that case, in the assignment 2, you don't have like you'll be given an Excel sheet. In that you only have wood, and wood is a reactant with oxygen. Those are reactants, and you'll get products. So products are syngas. So in that case, how do you actually simply calculate LCV of that obtained syngas? Uh, so yeah, the important observation that we made in our earlier calculations is uh, the final products, either from stoichiometric combustion of 1 mole of wood or stoichiometric combustion of syngas, are same. The number of moles of CO2 and number of moles of water and number of moles of nitrogen that we get are same. So in that case, how can we actually simply calculate in SMN2 LCV, lower calorific value of syngas? So yeah, I uh, yeah, highlighted in the former steps. Yeah, first you get enthalpy of products. Let's say that one as H products 1 for the stoichiometric combustion of wood. Yeah, then yeah, combustion of wood. Then change the temperature of that product temperature to 298 Kelvin. Then you will get H products. Yeah, whatever that CO2 and H2O and N2 at temperature of 298 Kelvin. So by actually taking air fuel ratio equivalent to 6.27, you will get that H products 1. Then yeah, you change. Then again you get in the second step again you get H products 2 for a given air fuel ratio. If that air fuel ratio is less than 6.27, definitely you will get other than CO2 and H2O. You will get more CO, H2 and all those species which has calorific value, and get that and change the temperature to 298 Kelvin. Then you have, as we have observed in the first step, we have H reactants, uh, which is here as H products 2, and we have H products, that is H products 1, and we also know number of moles of syngas. So directly uh, from the two steps we get H reactants and H products, and we know the number of moles. Then you can get the LCV of the syngas. And one more important thing is, yeah, most of the times if air fuel ratio is slightly higher, and that solid carbon char will not form, the char will be almost zero. So for example, if char is there, so the above 3 steps you can't follow in the SMN2. You can't actually calculate LCV like I mentioned in the above 3 steps. So you need to actually do manually, like I explained in the earlier steps. So you need to get the composition of syngas. Then manually you need to balance yourself by taking stoichiometric reaction with air. Then take heat of formations of products and reactants and calculate. If uh, solid carbon char is not forming, if it is that is zero, you can follow the first 3 steps, and directly from the Excel sheet you can get LCV of syngas. Of course, you will get from directly from the Excel sheet H products 2 and H products 1. For that you need to subtract, you need to deduct one from the other, and you know the number of moles, you can do that. So like, yeah, that's all. This step usually, students get confused how to calculate LCV of syngas when wood is there, and when syngas is obtained as a part of products. The important thing is here, syngas, you need to consider syngas as a separate fuel again, you need to take it as a separate stoichiometric combustion. Then you need to follow the same step. H reactants and H products you need to calculate, and you know the number of moles of say that particular composition, and get that. That's very important. Okay, that's all. I hope you all understand and make use of this presentation. Thank you.